Good morning. I am Prasannanjaneya Reddy, working as Assistant Professor in the Department of ECE, Institute of Aeronautical Engineering College, Dundigal, Hyderabad. In this session, we are going to discuss about embedded system applications, specifically in the healthcare. That the question we are getting in the previous question papers. So the question is, demonstrate the application of embedded systems in healthcare and propose a design for a wearable device to monitor the heart rate. So we are using different types of embedded systems in the medical field. Example, if you look at, if you go to the hospital in ICUs or some cases, we are observing some of the devices which continuously monitor the patient heartbeat. They are using some electrodes to monitor the heartbeat. Some of the devices connecting here to check the BP, blood pressure, status. Those will be displayed in the digital dashboard. That is also one of the embedded system. Display the digital information. To identify the diseases, we are using some scanners like electrocardiogram, ECG scan to check the heartbeat status exactly. Or 2D echo or MRI scan, CT scan to identify the diseases, X-ray to identify the fractures in the bones. So we are using different types of embedded systems in the healthcare. One by one we will check. First one is patient monitoring. So nowadays the human being population increases, but we don't have that much of hospital facilities. That is one of the reasons. So we need to, whenever we are going to the hospital, we need to wait in the queue for much time. To reduce that one, we are using some wearable devices to identify ourselves, like heartbeat. Nowadays we are getting smart watches. Those will be wearing to our hand, left hand. These will continuously display our heartbeat. Or in corona time, we are using some temperature scanners to identify the fever in that body temperature. Or in some cases, automatic BP machines, blood pressure measuring machines. Those will be keeping here automatically without pushing like this. Automatically, they will identify the blood pressure in our body. Okay. So, patient monitoring devices like wearable devices, example fitness trackers. So how many steps you are traveling, moving, running. While running, you are using how many feet we are walking, like that. Identifying that by the fitness trackers. Smart watches, continuous glucose monitors. Use sugar to check the sugar. Continuous glucose monitors. Utilize embedded systems to track vital signs like heart rate, blood pressure, blood sugar levels. This data can be transmitted to healthcare providers for remote monitoring and early intervention. Means these devices, whatever the data you are collecting here, that is uploading into the cloud. The other person, like our family members, our doctors, whenever they have free time, they will observe our condition. Is it normal condition or any serious condition? So before getting the serious, they will identify and take the precautions to avoid such type of serious conditions. Next, implantable devices, pacemakers. Suppose because of my food habits or because of my tensions, maybe I may get heart attack some cases. Or some cases my heart may be failing. In such case situations, I can replace whatever the functionality done by my heart, that will be replaced by the pacemaker to do the functionality of the heart. That is pacemakers. But defibrillators and insulin pumps rely on embedded systems to regulate bodily functions, deliver medication, and monitor patient health in real time. Real time in the sense current time. So now time is something 10 o'clock or 11 o'clock. At that time, what is the heart rate? After 1 minute, what is the heart rate? What is the continuously? Is it in the normal position or any serious condition? That will be identified here. Next, hospital bedside monitors. These systems continuously monitors patient vital signs such as heart rate, blood pressure, oxygen saturation, altering medical staff to any critical changes. If any issue come, it will send some alarms like that. Automatically, the corresponding persons take the precautions, nurses or anybody, family members. Next, medical imaging X-ray machines. So, embedded systems control the X-ray sources, image acquisition, and image processing in X-ray machines, enabling precise imaging and diagnosis. If you are not identifying the fracturing part in the bones, or some cases in brain where it is occurs, some problem occurs, if you are not identifying, means that will be spreaded and leads to loss of life. For that, we are going for diagnosis or scanning, brain scanning, or bone scanning, or body scanning, like that, to avoid the serious conditions. Before that, we need to identify and take the precautions. For that conditions, we are taking these scanning conditions. Next, CD scanners. These systems use embedded systems to acquire, means getting the knowledge, getting the information, process and reconstruct 3D images of the body, adding in the diagnosis of various diseases. Next, MRI machines. Embedded systems control the magnetic field, radio frequency pulses, and image acquisition in MRI machines, and providing detailed images of the internal organs and tissues. So the scanners scanning each and every part in the internal and give the details in the screen in a clear picture structure, like ECG, electrocardiogram, or 2D echo pulse, Doppler scanning. Next, medical equipment. Okay. In that, in ventilators, so some of the cases, some of the persons are in the ventilating conditions. Embedded systems control the airflow, pressure, oxygen levels in the ventilators, ensuring proper respiratory support for patients. Okay, we are giving some masks to get the air. Very breathing problems are there. Okay. Next, dialysis machines. For paralysis conditions, we are using these dialysis machines. These systems use embedded systems to control the flow of fluids, regulate blood pressure, and monitor patient vitals during dialysis procedures. Next, surgical robots. Embedded systems enable precise and minimally invasive surgical procedures by providing surgeons with robotic assistance and enhanced visualization. So in some conditions, human being may be getting some error, human error. At that time, we are designing robots to do the operations. Exactly. We are putting 0.5 measurement means we are putting 0.5 measurement. Exact measurement. Okay. For that purpose, sometimes we are using surgical robots. Robots will do the operations. Next, telemedicine. Remote patient monitoring. In some cases, it is not possible to stay in the hospital because of financial issues or availability of doctors and everything, beds availability. Or it is not possible to stay in the hospitals entirely every year, years after 365 days or 10 days, more than 10 days or more than 2-3 months or more than 1 year like that. Or some cases, patients may not feel better in hospitals. They want some home environment, atmosphere. So they are going to the home. At that time, we need to monitor the patient from the remote location. Okay. So remote patient monitoring. Embedded systems in wearable devices and home healthcare equipment enable remote monitoring of patients' health status, allowing healthcare providers to provide timely interventions and reduce the need for hospital visits. It is somewhat difficult to go to the hospitals frequently for the old people. Okay, because of lack of time by their children's or some conditions at the working time. At that time, we can monitor the patients remotely and take the precautions and give the medicines. Sometimes it is not required to go to the hospital. That much not required. That is not necessary based on the patient condition. It is normal means no need to go to the hospital. Whenever it is a serious condition, then only we are going to the hospital. With little bit precautions, we can take care in the home itself in some cases. That is remote location, remote patient monitoring. Next, teleconsultation. Embedded systems facilitate secure video conferencing and data sharing, enabling remote consultation between patient and health providers. Suppose if I am going to hospital, there is large queue. There are so many people are waiting in the queue. So, but lack of doctors or little bit availability of few people, few doctors, it is not possible to take care of all the people. So at that time, with little bit precautions and everything, from remote location itself, we need to interact with the doctors and take the precautions by the telecalling, video call or video conference. Drug delivery system, implantable pumps, example. These devices use embedded systems to deliver medicines at precise doses and intervals, improving treatment outcomes and reducing side effects. So in our body, based on the requirement, they will include the glucose and everything. Okay, we are inserting some pumps into the body. Whenever it is required, from the pumps we can insert, or automatically they will insert. Smart inhalers. Embedded systems in smart inhalers can track medication usage, provide reminders, and ensure proper inhalation technique. Okay, breathing issues. So it continues to track the breathing issues and take precautions. So the key benefits of embedded systems in medicine is reducing the frequent hospital visits with little bit precautions, or reducing the traveling time, waiting time in the hospitals, getting the accurate disease information because of lack of the technical that much of people available. Okay, reducing the cost, treatment cost by using this. We'll check on that one. So improved patient outcomes means real-time monitoring, means real-time in the sense. Now time is something 11 o'clock or 10 o'clock like that. Every time, whenever I want to check, at that time, I can monitor the patient from the remote location. Real time means current time. Here. Every time I can monitor the patient. Heartbeat status, BP status, sugar level status, heart pulse by using ECG. Okay. And the early detection of health issues, any brain tumor, any cancer issues, any dengue fevers. Okay, before spreading the disease to the entire body, I can identify with little bit by using the scannings. Early identification or early detection of health issues. And personalized treatment plans can significantly improve patient outcomes. The basic level itself, we are taking the precautions means we can clear that issue and improve our health. Okay, we can save if we are identified early and take the precautions for that. Next, enhanced diagnostic accuracy means advanced technology or advanced diagnostic device we are using here to identify exact problem. So we can take the precautions according to that only, instead of deviations in the identification of disease. Advanced imaging techniques and data analysis enabled by embedded system can improve the accuracy of diagnosis. So here is the problem, here is the problem, and here is the problem. Or in that one particularly. Otherwise, you may give treatment at other places means may not use. Okay. Where is the cancer? Where is the brain tumor? In which position exactly? In that part only we can do the operation. Otherwise, we may get other issues. Increased efficiency. Automation of tasks and remote monitoring can improve the efficiency of health care delivery. So, because of busy life and everything, it is somewhat difficult to identify the problems. So, we are using these advanced embedded systems like BP machines or heartbeat machines. If any issue will come, it will alert the corresponding people by ringing the alarms, by sending the SMSs to the corresponding doctors and their children and everybody. Okay, if the pulse is not getting means, it will ring the alarm. So, increased efficiency means automation of tasks and remote monitoring can improve the efficiency of healthcare delivery. Okay, next. Improve patient safety. Continuous monitoring and automated alerts can help to prevent medical errors and improve patient safety. Okay. Continuously monitoring means we can identify. So when the change will be occurred, at what time, in what conditions. So what is the reason to get the issue? So if identifying the reason means we can clear easily that issue. So, designed for wearable device to monitor heart rate. Here the ECG function of smartwatches such as the Apple Watch is based on the use of one positive electrode on the back of the watch and one negative electrode at the digital crown to record a single lead ECG. The standard procedure to record the ECG requires the user to wear the watch on the left wrist and launch the ECG application on the watch by touching the digital crown with a finger on the opposite hand. Okay. This creates a bipolar signal from the voltage difference between the left and right arms. Simulating the conventional ECG lead I record. Making a complete recording takes 30 seconds only. Then the HRV analysis could be performed based on the recorded ECG. This method can support only the ultra short term HRV analysis. Okay, this is by using this method we can measure the heartbeat and control the flow. The polar H10 strip with two ECG electrodes inside could be attached to the chest wall to continuously record an ECG for HRV analysis. Because this approach provides a much longer ECG recording period than a watch or band. It is the preferred method for long period monitoring of HRV. ECG sensors are considered the gold standard for HRV monitoring. PPG is a non-invasive technology that uses a light source and a photodetector at the skin surface to measure the volumetric variations in blood circulation. Accordingly, on all smart devices, the PPG sensor is located on the back of the device so that it can contact the skin. When the sensor starts to work, the light source emits the light to the skin tissue. The photodetector measures the reflected light from the tissue, hereby inferring changes in blood volume by measuring changes in the light absorption. The light absorption is proportional to the blood volume variations caused by beating of the heart. Thus, the intensity of the reflected light is different during systole and diastole. Based on this change, the pulse to pulse intervals determined in this manner are equivalent to the NN intervals from an ECG. And this equivalency has been verified during sleep or rest condition in numerous studies. So for this topic, I can refer the textbook is Introduction to Embedded Systems by Shibu KV and some online information. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.